Hello, my name's Jeff Messier. I'm a professor in electrical and software engineering in the Schulich School of Engineering. And the purpose of this video is to be a bit of a tutorial or get started video for the ENEL573 project. And in this video, I'm going to be talking about how to create a simple IP network in Packet Tracer. Okay, so regardless of which version of or which operating system you're running on your computer, the interface to Packet Tracer should look pretty much exactly like this. I'm running mine on my Mac, my M1 Mac. And what we're going to do in this tutorial is create a simple two host computer, one router network. And make it possible for IP packets to travel between the two host computers. And so the interface for Packet Tracer is essentially a drag and drop type interface where you can create and hook up your network devices by dragging them into this workspace. And once you have them all set up, you can each of these devices actually are running sort of actual Cisco operating systems, and so you can configure them just like you would a real Cisco device. Now, there's two modes for Packet Tracer, real-time and simulation. We're going to be using real-time, so we're not going to be touching the simulation mode. And I should say, at the outset, Packet Tracer is a hugely sophisticated tool. You can do all kinds of super cool stuff in it. If you're curious, I really encourage you to take a look at Cisco's online courses, all the tutorial videos that are available online as well. But for the purposes of 573, we're going to be using a fairly basic, very small subset of all of that functionality. Okay, so to get started, the first thing that we want to do is put down a couple of end devices. Now, there's a whole bunch of choices here. You can have a printer, tablets, smartphone with its cool little antenna there. But we're just going to use two PCs. So just drag and drop two PCs. And we're going to add a router. There's a whole bunch of different routers to choose from. We're just going to use the first one, 4331. And that's basically our network. However, the PCs are going to be connected to the router using Ethernet. And so we're also going to have to add Ethernet switches. And again, you can just choose the very first one here, the 2960. And so the PC is going to connect to the switch. And probably, well, you may have noticed already if you're sort of working along, when you do a mouse over on any of these devices, you get kind of a summary of its functionality. So here we get a huge list of ports for the Ethernet switch. So this particular Ethernet switch has 24 fast Ethernet ports, 2 gigabit Ethernet ports. If we look at the router has 3 gigabit Ethernet interfaces, and the PC only has 1 Ethernet interface. And so we're going to just now hook up our devices. And so we go to the little lightning bolt here. You can see in these cables, we can choose a bunch of different kinds of cables, straight through copper, crossover, fiber if we wanted, phone cable, coaxial cable. We're not going to worry too much about cable type, so we can just click on automatically choose connection type, and we get this little sort of picture of a wire and a jack. And that's our connection. Then we click on the little lightning bolt again, and we click on the little lightning bolt again, and we click on the little lightning bolt again. Now you'll see in my screen the Ethernet interface names show up when I make my connection. So this is the 000 gigabit Ethernet interface. This is the the second fast Ethernet interface. This is the first fast Ethernet interface. These don't appear by default, so you have to go into the preferences. Anyway, on the Mac, it's under preferences. On Windows, it might be under edit preferences. But you can click on I forget which one it was. Show device name labels. Oh yeah, always show port labels in Logical Workspace. So I clicked on that one. You can enable a few other things here if you find it helpful. All right, now it's time to configure the subnets and the IP addresses for our devices. So remember, the Ethernet switches don't have IP addresses, right? So they work at the MAC layer. They only go up to Ethernet. So they'll use MAC addresses, but we don't need to do anything IP related for the Ethernet switches. So we basically leave the Ethernet switches alone. However, our PCs and our router needs to be given IP addresses. So if we just double click on the PC, you can actually have a physical picture of the PC if you want, but I'm not going to talk too much about that. If you go under the config tab, we've got settings, algorithm, fast Ethernet, and then they gave us a Bluetooth interface, which we're not going to use. But we want to go to our fast Ethernet interface. Our port status is on, which is good. Make sure yours is on as well. And we're going to give this computer a IP address, and I'm going to give it 192.168.0.2, and the subnet mask fills in to something I'll use. We could change this if we wanted to, but I'm happy with that. 255.255.255.0. So that means our subnet network ID is 192.168.0.0. And that's it. That's all we have to do for the PC. And if you now hover your mouse over, you'll see that the IP address is set here. The next thing we need to do is configure the second PC. And I'm going to put it on a different subnetwork because it's got two different connections to the router, and typically routers connect to different subnets. So we're going to go into the PC, click under Config, Fast Ethernet 0, and I'm going to give this computer IP address 192.168.1.2, and I'm going to let the subnet populate there. And so the second PC has got the IP address that we want. Now, you'll notice something also in our mouse over. We don't have our gateway set, so we need to set a default gateway that the PC sends its packets to if it can't transmit them locally. So we go back in here, we go under Settings, and this gives us a chance to set the gateway. And so on this first subnet, I'm going to give this 192.168.0.1, which is going to be the IP address of the router. And I'm not going to bother with the DNS server because we're not going to use DNS. So if I click on that, then I do the mouse over. Now we have our gateway. I'm going to do the same thing over here for our PC. Go under Settings, 192.168.1.1, right? Because we're on a different subnet. Click that, and that looks pretty good as well. So now it's time to visit the router, right? And so this particular router has 3 gigabit Ethernet interfaces. We're using 2 of them. So the interface 0/0/0 is the one on the left. 0/0/1 is on the right. We double click this guy. Again, we see like a picture of what this would look like, which is interesting, but we don't need to dwell on it too much. Now, In the configuration tab, we see a few things that might look familiar. We've got a routing information protocol field. We're not going to touch that, but the simulator implements RIP. We have a static routing table. We've talked a lot about that in the lectures, but we actually don't need to do anything in this field for this particular network. So the Cisco routers are a little bit different than the Linux routers that we talk about in the lecture. So in the static routing tables that we've been using in the lectures, you'll remember that we basically have two different kinds of entries. One of them are sort of next hop entries where we specify the default entry. So if we don't know where a packet's supposed to go, we send it to the default entry. There's also some times where if a packet is bound for a particular subnet, we send it to a particular router computer on the network. We saw that a little bit with the example that we did in the lectures. And then there's entries for local transmission, right? So local transmission for the networks that are directly connected to the routers. So it turns out we don't have to specifically put in those local transmission routing table entries. They're created by default. All we need to do is go down to our Ethernet interfaces, turn them on, and give them the IP address that we want. So this gigabit Ethernet 0, and I'll move this over here, is connected to this first PC, and that's the one with subnet 192.168.0.0, and that's the proper subnet mask. And down here in this window, you can actually see the commands that would be typed on the command line if we had a terminal open to the router. And if we click on this CLI tab, CLI is short for command line interface, and this is the actual command line interface for the operating system that runs on the Cisco router. So it's a very, it's not exactly Linux, but it's similar to Linux. It gives you this very sort of basic command line terminal interface. And for any sort of kind of very sophisticated or even medium sophisticated networks, you end up having to work with the routers in this kind of command line environment. We're not going to be using a ton in here. I'm going to be showing you a few commands just to view the routing table after you create it, to check it. But if you were working with like a sort of a network that's like for a medium-sized company or university campus, you would be working in this environment a fair bit. But you'll notice that whenever we type something or we configure something in our GUI, it automatically generates the command line instructions that we would type to basically do the same thing. So when I put IP address 192.168.0.1 in the GUI, what happened here was the command interface gigabit Ethernet 000 was entered, and then the command IP address 192.168.0.1 was entered, and then an exit command was automatically entered because we wanted to leave the configuration for this particular gigabit Ethernet interface. So if we go down to the second gigabit Ethernet interface, you can see the command interface gigabit Ethernet 001 was typed in. We're now configuring an interface, and if I type in 192.168.1.1 and the subnet mask, that that generates the command IP address 192.168.1.1, and we could have just equivalently typed the commands into the command line interface. So the GUI is there. You don't have to worry about this too much, but just understand the GUI wouldn't be present if you were working with real network equipment, but this command line interface window would be exactly the same. So the last thing I need to do here is make sure I enable the port status. And now our 2nd gigabit Ethernet interface is enabled. So if we go back to the command line interface here, you'll notice that sometimes the command line says config, sometimes it says config-if. Config-if is when we're in interface configuring mode. Config is when we're just in general router configure mode. And when we do stuff in the GUI, it'll automatically put us in the proper configuration mode. But one thing we are going to need to do from the actual command line is query the IP routing table. And so we need to get out of configuration interface mode. And so I'm just going to type in exit. That brings us back into just general configuration mode. I'm going to type exit again. And we just get now our regular old router prompt. And so what I'm going to do is I'm going to type the command show IP route. And this is basically going to print out our IP routing table. And we're going to see we've got 2 subnets configured already automatically for local transmission, right? Remember I said that the local transmission entries are configured automatically. Now, rather than just one line like we had in the Linux routing table, Cisco actually prints this out as 2 lines. And so we've got C, which stands for connected, and L, which stands for local. And so C refers to our subnet. So this is our subnet. 0.0/24 is directly connected. And then it also, this local actually just refers to the specific IP address. So it gives /32. So when it's referring to just an entire IP address, it uses /32. So it says all the bits are, I guess, relevant. And this is the actual IP address of the gigabit interface. So you can basically take all 3 of these lines as equivalent to the local transmission line in the Linux routing table. And so if you see this, so you've got 0.0/24 connected to the gigabit Ethernet 0 interface, and subnet 1.0 connected to the gigabit Ethernet 1 interface, then you should be good and you can close this window. So now we're running in real-time mode. So that means that there's actual operating systems running on all of these little icons in our window. That's what we were interacting with in the routing intro, or sorry, the routing CLI tab. And if we go back to this PC, we can click on desktop and start a command prompt. And so we get a kind of a quaint Microsoft DOS little prompt here. And we can type the command ping to send packets from the host computer on the left to the host computer on the right. So first of all, let's see if we can ping or send packets back and forth between the left-hand PC and the router. So remember, the router has IP address on this subnet, 196.168.0.1. And so 68.0.1, and if I hit enter, we can see that we're getting packets and replies back from that IP address. This is a good thing to test just to make sure that transmissions on this local subnet are working properly. Now what I want to do is I want to send a packet from the PC on the left to the PC on the right. So I'm going to type in the ping command again, but I'm going to give the IP address 192.168.1.2. Right? And so this is an IP address that isn't on this local subnet. So that's going to cause the PC to send it to its default gateway, which is the router. The router has a local transmission entry for this subnet, and so it's just going to send it out on the network on the right. So if I hit enter, oh, there we go. It took a little while. So I get a reply back 192 from 192.168.1.2. Okay, so let's see if we can do the same thing in reverse. So for the PC on the right, desktop, command line prompt, I'm going to ping the gateway first of all, 168.1.1. No problem. I'm going to ping the computer on the left. Also no problem. So we've got communication from between the two PCs on the left with packets traversing the router. And so this is the basic sort of framework that you're going to need to know for the project. Now, in the project, you're going to have 2 routers and 3 local area networks. So you'll have 2 routers, 3 switches, and you will have to create a default entry and a next hop entry. And so you're going to do that with this static entry. So you're going to type in the network ID of the network that you're trying to reach that's beyond the router. You're going to put in the net mask for that, and then you're just going to put in the IP address of the router that's going to take your packets to that particular subnet. That's a little vague, but this is basically the main part of how you need to configure this for the project. And I think it's pretty self-explanatory if you think about it a little bit, and if you think about sort of what you're missing from your IP routing tables. You should be able to figure this out fairly quickly. Just a couple of things to note for the project. Don't worry about creating default entries because you've got a closed ecosystem, right? So the network is closed. So don't worry about creating default entries. You can just create sort of very specific next hop entries. So your routing table only needs to contain entries for the subnets that show up on the picture of the network that you're trying to design. And the second thing is, just make sure you test your network kind of step by step. Use the ping commands to make sure you've at least got connectivity to your local router first before you try to traverse multiple routers to reach a different subnet. And the final piece of advice for the project is it's really, really important that you first design your routing tables on paper, just like you've been doing in the assignments, rather than just trying to hack around inside Packet Tracer right off the bat. Make sure you design your and I know the Linux routing table format's a little bit different than what shows up in Packet Tracer, but still using the Linux routing table format, make sure you design your routing tables on paper. Make sure it makes sense. Using a paper example, make sure you can sort of trace the flow of packets between the computers on your network. Make sure your routing tables will guide the packets to their appropriate destinations. Get that all worked out and very solid in your mind before you dive into Packet Tracer. Don't try to sort of, within Packet Tracer kind of work it all out because, like the interface can be a little confusing. It's a little bit different than what we talked about in the lectures. So make sure what you want to do is solid in your mind before diving into the actual interface. But, the actual project is pretty straightforward, right? Like if you you just drag in your devices, you hook them up, and when you get your IP routing tables working, like it might take a little bit of time if you're working through some conceptual sort of roadblocks, but Once you know it's clear, you should be able to handle this exercise fairly quickly, at least in one sitting, I would think.